Whenever you build Cassandra clusters or you have already running Cassandra clusters, somehow you need to test how much stress you can put on your Cassandra cluster. I have a very good friend. His name is John Haddad. He's also known as Rusty Razorblade. He created a tool called Easy Cache Stress. So this is a wonderful tool we can use to generate some stress and generate stress test workloads on our Cassandra clusters. So today let's take a look at this tool called Easy Cache Stress. John Haddad, also known as Rusty Razorblade, has his website and he writes a lot of blog posts about Apache Cassandra and related tools. So please check out his website. Let's look at some history about the stress tool. Long back, when John was working at the last pickle, he was the original contributor to a tool called TLP Stress. Now, at this time in 2024, April, we are looking at TLP Stress. This is a very old project now, and it is no longer being actively maintained. So one thing to note is John Haddad was one of the original contributors for TLP Stress. Now that TLP Stress has become a little bit old and it is no longer being maintained, John has forked this project and created a new tool called Easy Cache Stress. So let's talk about Easy Cache Stress. This is the GitHub page where you can get the source code as well as you can get all the documentation and how to build and run Easy Cache Stress instructions from this GitHub page. Let's quickly take a look at Easy Cache Stress tool related documentation. This is the documentation page for Easy Cache Stress tool. As you can see here, Easy Cache Stress is a workload-centric stress tool for Apache Cassandra. This tool is written in Kotlin. We'll talk about Kotlin in a second. Workloads are very easy to write because they're written in code, and we have the ultimate flexibility to build whatever we want without having to learn and operate around restrictions of the configuration. Workloads can be tweaked via command line parameters to make them fit our environment more closely. So we can use this tool to generate a lot of stress on our clusters and control how much stress we are going to generate. Or we can basically use the pre-designed workloads to run some stress on our Cassandra cluster especially. One of the goals of the Easy Cache Stress tool is to provide enough pre-designed workloads out of the box so it's unnecessary to code up a workload on our own. And this tool is suitable for most use cases. For instance, it is very common to have a key value workload and want to test that. Easy Cache Stress tool, as you will see in this particular session, will allow us to very quickly out of the box run the key value pair related workload or several other workloads which are included in the tool. At present, Easy Cache Stress tool is mainly maintained and written by John Haddad, and he is very actively writing new options to make this tool better. Now, little earlier, we talked about this tool being developed in Kotlin. Let's talk about this language called Kotlin. Here is the home page for Kotlin language. Let's take a look at the Wikipedia to see what is Kotlin programming language is. Quickly reading from this Wikipedia here, Kotlin is a cross-platform, statically typed, general-purpose, high-level programming language with type inference. Kotlin is designed to interoperate fully with Java, and the JVM version of Kotlin's standard library depends on the Java class library. but the type inference allows its syntax to be more concise. Kotlin mainly targets the JVM but also compiles to JavaScript for the front-end applications such as React, or a native code via LLVM. For example, for a native iOS apps sharing business logic with Android apps. The language development costs are borne by JetBrains, while Kotlin Foundation protects the Kotlin trademark. You can also see that the Kotlin is designed and developed by JetBrains. It first appeared in the market in 2011, about 12 years ago now, and it has been very stable and very powerful, being used by Android development. In 2019, Google announced that Kotlin is the standard programming language and it is preferred for all the Android app developers. So, as mentioned earlier, EasyCast Stress tool is also developed in Kotlin. As you can see here, 99.4% of the code is written in Kotlin and a little bit of code is written in shell scripts. So make sure we understand the original TLP stress tool has now been not maintained for a long time. It has become old. And when I was talking to John, he wanted to restart development on this tool and he did not want to continue using the original name TLP Stress. So he forked that project and started writing code for EasyCast Stress. Obviously, he's adding new options. So he doesn't want to continue development on the old tool, but he's just refreshing the entire project. That's the reason he's moving it as a new tool called EasyCast Stress. Now that we got a good introduction to this tool, let's go ahead and see how to use this tool. Okay, let's now check how to clone the EasyCast Stress source code and compile it so that we can use it. Now, whenever I'm connecting to my Linux machines, I use this wonderful SSH client called MobaXterm. If you're not already using it, please try to check its features. It is wonderful and very futuristic. As you can see here, I have connected to one of my servers. Let's take a look at what is this server. As you can see here, I'm connected to Doom server as Cassandra user. Also notice that I'm running Rocky Linux release 9.3 on this server. We will be downloading the EasyCast Stress project onto this server and we will compile it. Also, this is kind of a client machine which will be connecting to our existing Cassandra clusters, and we will be running the EasyCast Stress tool on this server. Now, to compile EasyCast Stress tool, first thing we need is the JDK, the Java Development Toolkit or Java Development Kit. As you can see here, I have installed OpenJDK version 17 on this machine. Also notice that I have a Java compiler of the same version 17.0.10. So remember that when we want to compile the EasyCast Stress, we not only need the JRE, which is the runtime environment, but we also need the compiler, which is the full JDK. Only thing here to note is I'm using the Java version 17. Let's go ahead and clone the EasyCast Stress Git project. I will use this git clone command to clone the EasyCast Stress code. This command will require internet connection to download the source code. As you can see here, we have now completed cloning the EasyCast Stress Git code or Git repository. As you can see here, in this folder, the previous git clone command has downloaded the entire source code from GitHub for EasyCast Stress tool. As you can see here, I was looking for the jar files, which is a compiled code, and I only found one jar file, which is the Gradle related wrapper. And this is not related to the EasyCast Stress tool. Let's go ahead and compile this EasyCast Stress tool now. This is a very simple command, and by running this command, it will compile the source code and generate the final jar file for EasyCast Stress. As you can see here, after a few minutes, we have built this project successfully. Also notice that now when I search for the jar files, I found a new jar file called EasyCast Stress 6.2.0 snapshot-all.jar. This is the final compiled jar file for EasyCast Stress tool. I'm going to create a new folder called My Tools in the home directory for Cassandra user. I will now copy the compiled EasyCast Stress jar file into the My Tools folder. There is one shell script. We will copy this shell script also into My Tools folder. As you can see here, I have created My Tools folder in the home directory of the Cassandra user. I have copied the compiled jar file for the EasyCast Stress tool. I have also copied a shell script which was provided along with the source code. I will copy the full path of the EasyCast Stress jar file. Let us now edit the shell script which we copied from the bin folder from the EasyCast Stress source code. I'll simply delete these entries from the shell script. I will just comment out this line. I will now add a new entry for jar file and point it to the full path of the EasyCastStress jar file we compiled earlier. As you can see here, I have created a variable called jar and pasted the full path of the EasyCastStress tool we compiled, and we got this jar file. This script will try to run the jar file using Java. I will now save and close this file. This is the shell script which will run the actual EasyCastStress Java code. For convenience sake, I will create a soft link for this shell script and call it ECS. As you can see here, now we have a soft link called ECS which is pointing to the original shell script EasyCastStress. I will now modify my bash profile for Cassandra user and include the My Tools folder in the path. As you can see here, in my bash profile, I have added this entry which includes My Tools in the path. I will save and close the bash profile. Let us now exit from this session and reconnect to the Doom server as Cassandra user. Now that we have included My Tools folder in the path, we have ECS or the EasyCastStress in our path. We will now be able to execute EasyCastStress tool. So one thing to note, this is the jar file which was compiled using Gradle, but after compiling, this is a fully self-contained EasyCastStress Java code which can be executed. We use the EasyCastStress shell script or the soft link ECS we created earlier to run the EasyCastStress tool. We don't need any other files to run this tool. And remember, obviously we need Java to run this tool. I have two Cassandra clusters. Let's review them and see how we'll be able to generate some stress using the EasyCastStress tool for these two clusters. As you can see here, I have connected to Kratos1 server as Cassandra user. Notice that I'm running Rocky Linux version 9.3 on this server. As you can see here, I have Java runtime environment version 17 on this server. As you can see here, this is a 3-node Apache Cassandra cluster. As you can see here, my cluster name is GOW cluster and I am running Cassandra version 5.0 beta 1 on this cluster. Also notice that we have 3 nodes in this cluster. They all belong to Norse data center, Norse DC. The 3 nodes in this cluster are named as Kratos 1, Kratos 2 and Kratos 3. One thing to note about this cluster is I have not enabled Cassandra authentication on this cluster. Notice that since the authentication is not enabled on this cluster, Cassandra will allow connections using any username and password. Notice that I have connected as Cassandra user on selene1.oraclebyexample.com server. Notice that I am running Rocky Linux version 9.3 on this server. As you can see here, I have Java runtime environment version 17 on this server. As you can see here, my Cassandra cluster is named as returnal underscore cluster. I am running Cassandra version 5.0 beta 1 on this cluster. As you can see here, I have 3 nodes in my Cassandra cluster. The 3 nodes are named as Selene 1, Selene 2 and Selene 3. One thing to note is on this cluster I have the Cassandra authentication enabled. Since Cassandra authentication is enabled, we have to pass the correct username and password to establish the connection. As you can see here, authentication has failed because I did not provide the proper authentication information for username and password. Notice that now using CQLSH, when I pass the correct username passwords, I am able to connect to the returnal cluster. So for rest of these sessions, as you notice, we have 2 clusters, Cassandra clusters. We have this cluster called GOW cluster where authentication is disabled. Also, I have the second cluster which is returnal cluster and I have authentication enabled on this cluster. In this session, we will use EasyCass stress tool to generate some stress on these 2 Cassandra clusters. As you can see here, I have connected to the doom.oraclebyexample.com server. On this server, we have a folder called My Tools, and recently we have compiled and stored the EasyCastStress jar file in this My Tools folder. We included My Tools folder into our bash profile, so whenever we log into the server, by default, My Tools is included in the path. EasyCastStress shell script as well as the soft link we created called ECS are now available in our path. So ECS is just a easy soft link we have created for the EasyCastStress tool. We can simply run ECS command and which will print out all the help required to run this command. As you can see here, ECS command is now showing all the options possible to run EasyCastStress tool. Little later, we will go into this help and all the options provided under EasyCastStress tool in detail. We know that EasyCastStress tool has some workloads already built into it. So the first command I want to show you is the ECS list command. Again, remember ECS is nothing but a soft link created for EasyCastStress. Let us run the ECS command with list option. As you can see here, EasyCastStress tool already by default comes with all these workloads. We'll talk about these workloads, but we'll start with one of the very simple ones called key value workload. Let us use this EasyCastStress info command along with key value workload to see what it contains. As you can see here, this is the very basic workload where it will create a table called key value. It has two columns in it, a key which is a text data type and set as a primary key, and a value column which is also a text data type. This workload, when we run, it just creates a simple table called key value and it will generate some load on the cluster. So with EasyCastStress list command, we saw how to look at all the workloads, and using the EasyCastStress info command, we can get the detail for the given workload. In this case, workload name is key value. Note that the workload name is case sensitive. Let us now try to run the key value workload with iterations 10. I will explain all the options a little later, but what you have to get here is we are going to run EasyCastStress tool with a run option and we are running the key value workload. As you can see here, we got error. What happens is the EasyCastStress tool is trying to connect to Cassandra, which is running on the local node. But remember that for us, the current server, which is Doom, does not have Cassandra running. Our Cassandra clusters are running on different servers. So I have to use the host option to connect to one of the clusters. Let us rerun the EasyCast Stress tool using run command. We are running the workload key value with iterations of 10. Don't worry about what is iterations right now. Since our Cassandra is running on a different host, using this host options, I'm providing a host name called Kratos1, and that's where our Cassandra is running. So EasyCast Stress tool will connect to that host and generate some workload. So let's see what happens when we run this. So first thing you notice is it says it is creating EasyCast Stress key space. Then it is creating a schema, which is creating a table called key value, and we discussed about the key value table earlier when we use the info command. Then a little bit later it was initializing the metrics. It connected to the cluster, and using one thread it started running some iterations. Here are some metrics which we will review a little later. And after finishing the 10 iterations, it completed the stress. So this is the very basic introduction to how we can run a simple workload using EasyCast Stress tool. Now let's go to our Cassandra cluster and see what happened. If you notice, I'm connected to the Kratos1 server. Using CQLSH, I have connected to my Cassandra cluster. On this cluster, authentication is not enabled. That's why we don't have to provide username password. It just connects to the cluster as anonymous user and it allows all operations. As you can see here, we have a new key space called EasyCast Stress. This was created during the previous workload run we did using the EasyCast Stress tool. Also notice that under EasyCast Stress key space, we got a new table got created called key value. As you can see here, the key value table exists in the EasyCast Stress key space. The key space and this table was created by EasyCast Stress tool when we executed the run key value workload. Let us now run a select statement with a limit 5 on the key value table to see what kind of data the EasyCast Stress tool has generated. As you can see here, we have an interesting key which is a partition key and a random value which was generated, and all this data was generated using the EasyCast Stress tool. Right now when we executed it first time, we just used 10 iterations. Very little data was generated. Let us now re-execute the EasyCast Stress tool using the key value workload, same 10 iterations, connecting to the Kratos1 server. Let us carefully review the metrics printed here. If you notice under writes, count says 6. That means there were 6 writes generated. Under reads, we see 4 counts. Under deletes, there is 0 counts, meaning there was no data which was deleted during this run. And also under errors in the count, we don't see any errors. Let's go back to the table and query to see if there is more data now. As you can see here, we have more data now. Let's now run the same workload using iterations equal to 10,000. I'm writing it as 10k. Let's see what happens. So as you can see here, I have requested the EasyCast Stress tool to run a key value workload using 10,000 iterations. If you notice, it did about 5,000 writes and 5,000 reads. Obviously, this workload does not have any deletes. As you see, running EasyCast Stress tool is so easy with a very minimal setup. Without doing much here, we have generated 10,000 transactions on our Cassandra cluster. In next session, we will look at more options and more workload related features where we can generate a lot of load on our cluster. Let's talk about all the options available with EasyCast Stress tool. This is the EasyCast Stress documentation webpage. As you can see here, we can use the CL flag for consistency level setting. The standard consistency levels available in Cassandra are available with this option. For example, when we are running EasyCast Stress workload, we would like to use a specific consistency level for that workload. So we can use this flag called CL and pass, let's say for example, local quorum as the consistency level. We can use this compaction flag to specify what kind of compaction we would like to apply to the table being created by the workload. As you can see here on the right side, this is the full Cassandra style compaction declaration. When using this compaction flag with EasyCast Stress tool, we can use the short form. For example, we would like to use time window compaction strategy and the time window should be of 1 day. Then we can use this option called TWCS, 1, days option. We can use this compression flag to specify what kind of compression should be applied to the Cassandra table when we run a workload using EasyCast Stress tool. Notice that the concurrency flag has been deprecated. Let's skip over this one. We can use this coordinator only flag for when we want to run the EasyCast Stress using round robin method between the nodes without using tokens. This will require additional settings in the Cassandra env.sh. We can use this core connections flag to specify how many connections we would like to establish from EasyCast Stress tool to the each host in Cassandra cluster. By default, EasyCast Stress tool will use 4 connections per host. We can use this CQL flag to run additional CQL commands while creating schema using EasyCast Stress tool. By default, EasyCast Stress tool will publish all the metrics using Prometheus endpoint. But if we want EasyCast Stress tool to write metrics into a CSV file, we can use this option. We can use this DC option to specify for EasyCast Stress tool to connect to which data center in our Cassandra cluster. The flag delete rate or deletes is a very important flag, and this can be used to generate delete workloads during EasyCast Stress run. For example, delete rate can be anything in between 0 and 1. Say we specify delete rate as 0.1, that means 10% of the workload will be delete transactions. Remember that EasyCast Stress tool will create a default key space during run mode. We can use this drop flag to specify to drop the existing key space and create a new one during the run phase. We can use the duration flag to specify how long we want to run the stress test. For example, this can be specified as 1 day, 3 hours, 15 minutes. Notice the letters we can use D, H and M to specify the days, hours and minutes. We can simply use this as 1 day or maybe just 3 hours or for 15 minutes. This is a very flexible configuration for duration for which we can specify EasyCast Stress tool to run for the specified amount of duration. Field is an advanced option to override the default data being generated for each column. We already used this host flag. Remember when we were running a workload and we wanted to connect to a remote Cassandra host, we used this host flag. This ID option is a very interesting option. When EasyCast Stress tool is running a workload, it will by default generate partition keys using the default 001 as a prefix. But let's say we want to identify or differentiate between two different runs, then we would like to generate our own prefix for the partition keys. And that is possible using this ID option. Earlier, when we executed a default, very basic EasyCast Stress workload, we have used this option called iterations. We can specify how many transactions we want to run, or this is like operations we want to run. Let's say iterations are 10, that means we would like to run 10 operations. So the 10 operations will include writes, reads and deletes. So one advanced option for the iterations is we can specify a number with a k for doing 1000 iterations. Let's say for example, when you do a 10k, that means it is 10,000 iterations. Similarly, we can do 10m for making it 10 million transactions. Or we can write 10b for making it 10 billion operations. So we can use k, m and b to specify how many iterations we want to run. So remember that we can either use iterations or the duration. We cannot use both of them together. The key cache option is to specify what we would like to cache. By default, all keys are cached. By default, EasyCache Stress tool will try to create EasyCache Stress key space in the Cassandra cluster. But let's say we would like to use our own custom key space for running EasyCache Stress workload, then we can use this key space option to specify the key space name. Using max connections option, we can set the max number of connections per the Cassandra host, and EasyCache Stress tool by default sets 8 as maximum connections. Similarly, max requests option can be used to specify how many max requests should be sent per connection. By default, EasyCache Stress will send over 32,000 requests per connection, which might be a little bit high. Max RLAT and max WLAT options are very interesting. We can use these two settings for max read latency and max write latency allowed by the EasyCache Stress tool. Let's say we can specify that max read latency is 20. What EasyCache Stress tool does is it will try to simulate a max latency of 20 milliseconds. We know that by default EasyCache Stress tool will try to create the key space and the table required for a workload. We can specify no schema option, and that will skip the creation of the table and the key space. This is very useful when we would like to create our own table and our own key space, and then EasyCache Stress tool should not recreate that schema. Let's talk about partition generator. In general, for EasyCache Stress tool, we don't have to change this option. But the method used to generate the partition keys, it supports random, normal, Gaussian and sequence mode. By default, it generates all the partition keys using random method. So in general, I don't see a very big need for changing this partition generator option. Partitions is a great option where we can specify how many max partitions we would like to have during our workload. Using this password option, we can specify the password required for authenticating to the Cassandra cluster. EasyCache Stress tool also allows for a pre-population of some data into the table when it is starting the workload. So we can use the populate option to specify how much data should be pre-populated. For example, we can say pre-populate 1,000,000 records and then run the workload. While connecting to Cassandra, by default, all connections will go to 9042 port. But what if we are running our Cassandra on a different port? Then we can use this port option to specify what is our port where Cassandra is listening. As mentioned earlier, EasyCache Stress tool publishes all its metrics on this Prometheus port. In general, we can leave the queue depth option to the default. We don't have to change it. Rate is a very interesting option with EasyCache Stress. The rate limiter accepts a number, and by default it is 5,000. What it means is basically Initially, when EasyCast Stress tool starts up, it will start with a smaller rate and it slowly increases the rate. Now, in the general workloads, in the production workloads, you will never have a constant rate of data coming in. Most likely, there is a variable rate, and this particular option can be used to simulate that you want to reach to a specific amount of rate during the workload. Read rate or the reads option is very interesting. Just like the delete rate, what we can do here is we can specify a value between 0 and 1 to specify how many reads should be executed during the workload. Let's say I want to have 80% of reads. Then we can specify the read rate equal to 0.8. Replication option is very interesting for the key space creation. We might decide to do a different kind of replication, and it is easy to specify replication equal to whatever strategy we want to use. By default, replication will be done as simple strategy with replication factor of 3. Just like the key cache, we do have an option here for row cache setting. We don't need to tweak this. In general, we don't have to mess with the row cache or the key cache values. If at all we have enabled SSL on our Cassandra cluster, then we have to use this SSL flag to enable it or disable it. By default, SSL is disabled. Whenever we run a workload with EasyCast Stress tool, it will use the default one thread to run its workload. We can increase these threads. For example, we would like to run 4 threads. When we do some more testing, we will be trying out with different values for threads. When EasyCast Stress tool is creating a table for its workload, we can specify what is the TTL to be defined. By default, table level TTL is disabled by EasyCast Stress tool. We can override the TTL value using this TTL option. When authentication is enabled on our Cassandra cluster, we need to pass the username and password, and using this username option, we can pass the username for authentication. Some of the workloads provided by EasyCast Stress tool have dynamic parameters. We can use this workload.key equal to value option to override those dynamic parameters. As we discussed here, EasyCast Stress tool has so many options, making it very powerful to use. Let's now run some workloads using EasyCast Stress tool along with some options. As you can see here, we executed similar workloads before. What we are asking here is to run 500 operations or 500 iterations using iterations flag. Let's run it and analyze the output. As you can see here, this workload was executed using 500 iterations. Iterations are nothing but operations here. So total number of reads, writes and deletes will be 500 approximately. For iterations option, we can also specify the iterations using 2K for 2000 operations, or 2M for 2 million, or 2B for like 2 billion. So we saw these options earlier. On this command, we are running 2000 operations for this workload. As you can see here, the workload with 2000 iterations or 2000 operations has completed. Instead of running operations or the number of iterations, let's run a workload with duration. So using this duration flag, I am mentioning here that I want to run a workload for 1 minute. If you remember, we can specify something in days, hours, and minutes. Here we are just going to run a workload which will run for 1 minute duration. So with duration flag, we can specify how long we want to run the operations. It is not limited by the number of operations, but it is bound by the duration we ask it to run the workload for. So here we executed a workload which ran for 1 minute. So notice that we can specify the duration in hours, minutes, or days. And in this case, here on this command, I am asking to run a workload for 1 hour 15 minutes. As you can see here, this particular workload is going to run for 75 minutes. Obviously, I will cancel the run by doing a Control C. I will stop running this workload. So remember that for the duration flag, we can specify the duration in days, hours, and minutes, and we can combine them. When we have multiple duration values, we can put them in double quotes to specify the duration. If you remember, we cannot use both iterations and duration in the same workload. So let's run this command and see what kind of error will come out. Here I'm asking to run 2000 iterations for a duration of 2 minutes. And we know that this is not possible. So we got an error here. Look at the error. It says duration and iterations shouldn't be used both at the same time. Please pick just one. So remember that for a workload, we have to either use iterations or the duration. We cannot use both of them together. So far, we have executed many workloads, but we were just using a single thread for all those workloads. Let us now run a workload for a duration of 1 minute with 4 threads. So notice that we just executed a workload with 4 threads and it has started thread 0 to 3, 4 of them, and it executed the workload for 1 minute duration. As you can see here, I would like to run 10,000 iterations. By default, it was using the default settings for core connections, max connections, and max requests in the previous workloads. On this one, I would like to establish 2 connections per core or per host. Maximum connections I want are 4, and the max requests should be 300 at any given point of time. So we'll run this operation right now and see what happens. Notice that when we executed this workload, it was using the default consistency level of local 1. Next time when we run a workload, let's look at the consistency level settings and see how to use CL flag. Let's run a workload with local quorum as the consistency level setting. As you can see here, we change the consistency level to local quorum for this workload. So note that we can use the CL flag to specify the consistency level for a workload. Notice that I'm using some special flags here. First one is drop option. Remember that the key space and the schema which was created during the previous run, if it already exists, this workload will first drop the existing schema and the key space. Notice that I'm using the replication flag to specify the network topology strategy for replication, and this is specific to the key space when it is creating the key space. Notice that during the workload run, it executed a create keyspace command and it used the replication as we mentioned it in the workload settings. In this workload, if you notice, I'm specifying the compaction settings for the table. The compaction settings I'm providing are time window compaction strategy with a 1 hour duration. Also, using this compression flag, I'm specifying that my compression chunk length should be 4 kilobytes using LZ4 compressor. Notice that I have also mentioned the time to live setting as 7200 seconds. 7200 seconds is equal to 2 hours. So the time to live on the table setting will be 2 hours. As you can see here, now during this workload, the table was created with specific settings for compaction, compression, and time to live. So far, we have been executing the workloads with their default settings, like how much writes and how much reads will be generated. Let's now use read rate and delete rate options to specify how much read and delete should be done. And based on the read and delete, writes will be defined automatically. So let me explain. Read rate here is 0.7. That means about 70% of this workload will be reads. Delete rate here is 0.1, which means about 10% of the operations will be deletes. So if you add up reads and deletes, about 80% of operations are reads plus deletes, then 20% remaining will be writes. Let's run this workload now. So you can see here, we have generated about 5000 operations. Out of 5000 operations, about 70% of them are reads, 10% of them are deletes, and remaining are the writes. So we can use the read rate and delete rate to control how many reads versus deletes are happening during a workload. Remember that read rate and delete rate will define how much writes will happen during the workload. Imagine we would like to pre-populate the table with 10,000 rows And then entire workload should just do reads. It should not do writes or deletes. Then we can run this particular workload with populate equal to 10k and read rate equal to 1, which is 100% reads. As you can see here, during the pre-populate stage, we requested it to populate 10,000 rows, and it finished pre-populating the 10,000 rows during the workload. Then it started doing 5,000 operations, and all of them are reads. So this is how we can generate 100% read operations during our workload. Let us check how to generate 100% delete operations during a workload. What I'm mentioning here is there should be 0 reads and there should be 100% deletes. Obviously, there will not be any writes. As you can see here, we have generated 5,000 operations and all of them are deletes. There are no writes and no reads. Now what if we would like to generate only write workload and there should be 0 reads and 0 deletes? Then we can use these flags to run the workload. During this workload, we have used a flag for read rate equal to 0 and delete rate equal to 0. That means we would like to generate 100% of writes, and all 5,000 operations here are writes. We had 0 reads and 0 deletes during this workload. So far, when we executed our workloads, we never controlled the rate. So, for example, we would like to control how many requests per second should be executed. So, rate will control that. Remember that EasyCast stress tool will start with a 10% of the rate and it will slowly increase it to the 100% rate. In this workload, what we are specifying is to run 10,000 operations with a rate of 300, meaning total 300 requests per second. But remember that initially it will start with 30 operations per second. So notice that we have executed a workload with the rate of 300 and stepping rate limiter was set between 30 and 300. So 30 is the 10% of 300. So basically requests per second will start with a 30% rate and slowly increase. Notice that this rate is very visible when you look at this column, which is requests per second. It started slow and then it reached to the max during the workload. Similar to the rate, we can also specify the max latency we want. So for example, if we want to keep the max read latency to less than 50 and max write latency to 120, then we can execute the workload using these settings. This is a very small workload which executed only 10,000 operations. But imagine we are running a workload which runs for 2 hours. Then the latency numbers will be really interesting and we should run the workload for a long time to notice that latency settings. But main takeaway here is this is how we can control the max read latency and max write latency using these two flags. As you can see here, I'm running a very small 5 operations workload. I'm going to drop the existing schema and I'm going to just generate the write workload. No reads and no deletes. EasyCast Stress tool has completed running the workload. As you can see here, I'm connected to my Cassandra cluster and I'm using the EasyCast Stress key space. As you can see here, the key value, which is the partition key, is automatically generated by the EasyCast Stress tool. Let's run the same workload as the previous one. We will generate 5 operations. All of them are writes. But only difference here is we will use the ID flag to specify the date, today's date basically, and see how this will be used to generate the partition keys. EasyCast Stress tool has completed running the workload. Let us now query the table and look at how the keys look like. As you can see here, now the partition keys have the date as a prefix in their partition keys. This is very useful when you want to run multiple workloads and identify which records were generated by which workload. So you can provide a specific ID for each workload. Let us now execute a workload with a different ID. As you can see here, now we have three kinds of partition keys. The default partition key, which starts with 001, is the no ID workload using EasyCast Stress tool. During one of our workloads, we specified the date as the ID for EasyCast Stress tool. Most recently, we have executed this workload with the ID set as a custom string. So when we are running EasyCast Stress tool workloads with a specific ID column, it is very useful to differentiate when you want to run multiple workloads at the same time or at two different timing, but you want to measure how they are running or what is the performance. Let us now run a very simple 5 operation workload. I'm going to drop the existing schema and recreate a new schema during the workload obviously. We would like to generate only writes during this workload, no reads and no deletes. EasyCast Stress tool has completed running the workload. Let's go ahead and take a look at the data, how data looks like from this workload. As you can see here, when we executed the key value workload with 5 operations, this is the data generated by the EasyCast Stress tool. Let us now look at how to use the field option to customize the values generated in the value column. So let us run this workload, which is a small 5 operations, only writes. But special thing here is using the field column, we are specifying the key value table, the value column. We should use a random function which will generate a string of length between 10 characters and 15 characters. Let us now run this workload. EasyCast Stress tool has completed running the workload. Let's go take a look at the data now. As you can see here, the value column now only contains less than 15 characters length strings. Shorter length strings were generated for the value column in the key value table because we use this random function to generate only strings between 10 characters and 15 characters of length. Let us now generate a new workload which will use a book function. And what is a book function is the EasyCast Stress tool has access to certain text which is from books. And what we are saying is extract 10 to 15 character strings from the existing data that EasyCast Stress tool has and generate the value field using this function called book. Let's now take a look at our data which was generated by EasyCast Stress tool. As you can see here, the values for the value column were generated using the book function which EasyCast Stress tool provides. EasyCast Stress tool also comes with one more function called first name. This will generate a generic first names for the value column. Let us now take a look at the data and see if value column now contains some first names. As you can see here, the value column now contains first names. This was possible because EasyCast Stress tool comes out of the box with a first name function. Similar to first name function, we do have an option for generating last names. Let's run this workload and see how the last names are generated. Let's take a look at the data. As you can see here, during the first run, we use the first name function to generate first names for the value column. During the second run, we use the last name function to generate the last names for the value column. EasyCast Stress tool comes with one more undocumented function called US cities. These are the cities in United States of America. Let's use this workload to generate 5 records which will have US cities as their value column. Let's now check the data. As you can see here, EasyCast Stress tool has generated the value column using US cities. It randomly picked up some cities from the United States to generate the value column. EasyCast Stress tool comes out of the box with 5 different functions: random, book, first name, last name, US cities. Let's now talk about what if we want to generate the key value workload, but each of the partition should be very large partition. We can use the random function for the field option. So what we are saying here is, using the field option for key value table, the value column, generate 100,000 characters to 150,000 characters random string. Let's run this workload. This workload has completed running. What we have done here is we have generated the partitions with large amounts of data in a single column. Let's go take a look at one row to see how the data looks like. As you can see here, I would like to take one row value column with a limit 1. And you can see it generated a value column which has lots of text data in there. Let's run another similar workload with lot more data in a single column. So what I'm saying here is, for the value column, use the random function and generate 1 million characters to 2 million characters length. This is a lot of data for single partition. Using this random function, we have generated a very large partition data. Let me decrease the font so you can see how much data is sitting in this single column. That's a very small font, and that's a lot of data sitting in one column. So we obviously, using the random function, we have generated a lot of data in a single partition. So as you saw, EasyCast Stress tool comes out of the box with lots of different options, and when we combine these options, it becomes very powerful tool to stress our cluster or to see what is the limits for our cluster. We can break it or make it. As you can see here, I have logged in as Cassandra user on my Doom server. Using EasyCast Stress tool, we have recently executed many workloads which look like this. What we are doing here is we are asking EasyCast Stress tool to run a key value workload. This workload will have 50 iterations. Also note that I'm connecting to Kratos1 node, which is part of a Cassandra cluster. Let us now run this workload and see what happens. As you can see here, EasyCast Stress tool will try to create a key space if it does not already exist. Also note that EasyCast Stress tool will try to create a key value table if it already does not exist on the cluster. What if we don't want EasyCast Stress tool to use the default key space and we would like to use the custom key space for running these workloads? Let's talk about the options. As you can see here, this is exactly same workload as the previous one, but this time we are using a new flag called key space. Using this flag, I am specifying EasyCast Stress tool to create a key space called ECS_KS. As you can see here, EasyCast Stress tool now tried to create a key space called ECS_KS and executed the workload. So remember that the Cassandra cluster, where Kratos1 is one of the nodes, we don't have Cassandra authentication enabled. Since authentication is not enabled, EasyCast Stress tool is able to drop or recreate key spaces and tables whenever it requires to do it during the workload executions. Let's talk about a Cassandra cluster where authentication is enabled, and we are going to grant only very limited privileges to the user, which will be used by EasyCast Stress tool. As you can see here, I have connected as Cassandra user on my Selene1 server. Selene1 is part of this Cassandra cluster, which is called returnal_cluster. As you can see here, we have 3 nodes in this Cassandra cluster. As you can see here, using SQLSH, I was trying to connect to the Cassandra cluster. Notice that we got an authentication failure message because we have authentication enabled on this cluster and we have not provided the username password to log into the Cassandra cluster. Let us now try to re-log in into Returnal cluster using SQLSH and also passing the username and password. As you can see here, we are now successfully connected using SQLSH to the Returnal cluster. Note that Thor user on this cluster is a super user. Please note that I have already created a key space called ECS_KS. Also, note that there are no tables in this key space. Note that I have also created a user called ECS_user on this cluster. ECS_user has very limited privileges. As you can see here, ECS user can only select or modify data in the ECS_KS key space. I am back on my Doom server. Notice that now I would like to run a key value workload using EasyCast Stress tool, and I'm connecting to the node Selene1, which is part of the Returnal cluster. Notice that we got an authentication error. Remember that on Returnal cluster we have enabled the Cassandra authentication. So we have to provide username password to connect to Cassandra cluster. Again, I'm trying to run the same workload as previous one. I'm connecting to Selene1 node, which is part of the Returnal cluster. This time I'm providing a username and password for authenticating to the Cassandra cluster. Notice that we got a different error now. As you can see here, ECS user has no create permission on any key space on the Cassandra cluster. Remember that ECS user can only select or modify the data in any of the tables in the ECS_KS key space. ECS_user does not have any create privileges on the Cassandra cluster. We can use the EasyCast Stress tool info command for a workload. As you can see here, to run this workload, it will require a table called key value. Let us now go back to the Cassandra cluster and create this key value table in the ECS/KS key space. As you can see here, using SQLSH, I am already connected to the Cassandra cluster. I am also using the ECS/KS key space, which was already pre-created. As you can see here, in ECS_KS key space, I have created a key value table. As you can see here, now we have key value table in the ECS_KS key space. As you can see here, this table is empty right now. I am back on my Doom server where we can run EasyCast Stress tool. Let us now try to run a key value workload using EasyCast Stress tool. I'm going to generate 50 operations. I'm connecting to Selene1 node, which is part of the Returnal cluster. I'm providing the username and password. I want EasyCast Stress tool to use this key space for generating this workload. As you can see here, we got a different error now. Still complaining about create permission on the key space. Remember that EasyCast Stress tool will try to create the key space and table during the execution of the workload. But in our case, the key space and the table are already existing. So let's see how to instruct EasyCast Stress tool to ignore creating these key spaces and tables during its workload. Let us now rerun the same workload we executed earlier with EasyCast Stress tool. The only difference here is there is a new flag called --no schema. If you remember, when we instruct no schema, EasyCast Stress tool will ignore creating the key space and the table. It will just assume that these things already exist in the Cassandra cluster, and all it will try to do is generate the operations. Let us now run this workload and understand what it is doing. EasyCast Stress tool has successfully completed running the workload. If you notice here, it says skipping key space creation. That means key space is no longer created by the EasyCast Stress tool. It is just using the key space which is already existing in the cluster. Note that it is saying creating tables, but actually speaking, we mentioned not to create the schema. So EasyCast Stress tool is not going to create any table. It's just going to use the key value table which is already existing in the Cassandra cluster. If you notice, this workload has generated 23 writes and 27 reads. As you can see here, now we can see data in the key value table which was generated by EasyCast Stress tool. So using EasyCast Stress tool, we can provide username and password for authenticating to the Cassandra cluster. We can also pre-create the key space and table according to our own configuration and skip the creation of the table and key space via EasyCast Stress tool. This is possible through an option called no schema along with EasyCast Stress tool. As you can see here, I have logged in as Cassandra user on my Doom server. So far, using this server, we are running the EasyCast Stress tool. Let us now execute a basic workload using EasyCast Stress tool. We notice that every time we execute a workload using EasyCast Stress tool, it prints out a lot of metrics. Let us now understand all the metrics printed by the EasyCast Stress tool, not just the on-screen metrics with EasyCast Stress tool, but it also has other ways we can extract these metrics. Let's understand what options we have to gather these metrics from EasyCast Stress tool. Let us now first understand the on-screen metrics when we execute any workload with EasyCast Stress tool. These are the metrics for write operations during this workload. Notice that the last row is the summary of the entire workload. It will always print the last row as a summary during any workload execution. As you can see here, there were total of 1056 writes during this workload. It prints the P99 latency values during the workload execution. It also has this column called requests per second. EasyCast stress tool for on-screen metrics prints 4 different metrics here. It has metrics for writes. It has metrics for read operations. It has metrics for delete operations. And if there were any errors, they're printed here in the errors section. When we are running any large workloads, identifying how the workload is being executed with how much latency and how many requests per second are running is very important. That's the reason EasyCast stress tool makes it easy for us to look at all the metrics during the workload. Let us now run this simple workload, but the duration here is 15 minutes. Execution of this workload has started. Note that every time you execute a workload with EasyCast stress tool, the metrics are also published as a Prometheus endpoint. As you can see here, I have navigated to this URL and I can see the EasyCast stress tool metrics in Prometheus format. These are the number of selects executed so far during this workload execution. These are the number of writes, here they are also called as mutations, generated so far using EasyCast stress tool during this workload. These are the number of deletes generated so far during the EasyCast stress tool execution. If there were any errors, they are displayed here as errors underscore total metric. If you remember, we can ask EasyCast stress tool to pre-populate data before running the workload, and they are displayed as populate mutations underscore count metric. Notice that with every metric in Prometheus format, it also provides different quantile metrics. By default, when you start the EasyCast stress tool execution, it will publish the metrics on port 9500. Note that using Prometheus port option, we can change the default port where Prometheus metrics are published by EasyCast stress tool. So far we saw that EasyCast stress tool prints metrics on screen and also publishes the metrics in Prometheus format. There is one more option. We can publish the metrics to a comma separated values file. Using the CSV flag, we can publish the EasyCast stress tool metrics into a comma separated values file. EasyCast stress tool has completed running the workload, which has generated 20,000 operations. As you can see here, this is the comma separated values file which contains the metrics generated by EasyCast stress tool. When we are running any stress workloads using EasyCast stress tool, note that we have metrics published on screen. We can also get the metrics from Prometheus endpoint, and we can also publish these metrics into a CSV file. So far we have discussed a lot about EasyCast stress tool, which can generate stress tests on Cassandra clusters. Let's take a minute here and discuss about other tools which we can use to generate some stress on Cassandra clusters. The first tool I can think of is there is a basic Cassandra stress tool which is published or distributed along with the Cassandra software. The second stress tool for Cassandra clusters I can think of is NoSQLBench. I have used NoSQLBench in the past. It is more complicated than EasyCast stress tool, but also remember that NoSQLBench is not just limited to testing Cassandra, but it can generate workloads for other databases. So definitely take a look at NoSQLBench, but also note that EasyCast stress tool is the best and easy tool available to generate some stress on Cassandra clusters. So far we have discussed a lot about EasyCast stress tool. We started with the basic introduction. I tried to introduce you to TLP stress. That's where EasyCast stress tool came from. We talked about a little bit on how EasyCast stress tool is developed using Kotlin language. Then we downloaded and built the EasyCast stress tool using the Java development kit. We used two different Cassandra clusters and generated some workloads using EasyCast stress tool. We went into basics of EasyCast stress tool. We looked at how to extract help from the EasyCast stress tool. We looked at the documentation page. We know that EasyCast stress tool can generate several different workloads. We saw how to get information about a workload from EasyCast stress tool. We discussed about all the options available with EasyCast stress tool, and we also went into running EasyCast stress tool with all those options we saw earlier. We executed EasyCast stress tool workloads on a Cassandra cluster which does not have any authentication enabled, and then compared it with the Cassandra cluster which has authentication enabled. We looked at the metrics produced by EasyCast stress tool. We talked about all the different options to extract the EasyCast stress tool metrics. We talked about the other stress tools available for Cassandra. So hopefully you like the EasyCast stress tool and use it in your workloads. Also remember, all the open source developers love to get a star on their GitHub page. So don't forget to give a star for EasyCast stress tool on GitHub. You know me as Sarma Paidipalli, or also known as Oramad. I have been working with Oracle database for more than 25 years, and I started working on Apache Cassandra in 2016. I work with Apache Cassandra and also Apache Spark. I have a YouTube channel where I produce a lot of Cassandra content. Please check it out. I have a GitHub page where I publish all my open source work. I have published many Udemy courses. Please check out these courses. They're very useful if you want to learn Cassandra. I'm very happy that Cassandra community has recognized me as Cassandra Catalyst during December 2023.